Hello. In this lecture, we will be going over slice types. More specifically, we'll cover slices and then how they apply to strings. As a review, we've covered arrays in the past, and they work as a contiguous collection of objects of a certain type, and the size of the array must be known at compile time, and arrays live on the stack. In contrast, slices, which we denote with ampersand and then brackets, let us view into or immutably borrow from any contiguous collection, and that includes arrays. And this original collection can live anywhere, so it can either live on the stack or the heap. In this case, if we're borrowing from an array, it lives on the stack. But it could potentially borrow from something that lives on the heap as well. And the size of a slice doesn't need to be known at compile time. And also, we don't have to borrow the whole array, we can just borrow a subarray of it. To show what this looks like in code, here we first have a mutable array, and this array contains i32s, and there are 5 of them, right? And we see that's what's happening here. When we do this ampersand x, we can get a slice of i32s, and this is immutably borrowing from x. And by default, this will borrow the whole array, so it'll borrow all 5 elements. To get a specific section, a subarray, we can provide it some indices, and it'll borrow from indexes 1, 2, and 3, because this is exclusive. If we wanted to do inclusive, we could put it as equals 4 instead. So inside this slice, you would get the elements 2, 3, and 4. And then here, when we try and assign 6 to the third element of x, we get an error, because under the hood, this is immutable borrow, but we already have 2 slices which are immutably borrowing from x, right? And we see that this slice is used later on. So this causes an error, because we can either have one mutable borrow or an infinite amount of immutable borrows, right? So this is kind of explaining what this code is about. Now we'll talk about how slices interact with vectors. So unlike arrays, the vec is a mutable collection of objects, and that it's variable size and it's not known at compile time. And under the hood, it stores an array in the heap, right? Then since slices can either borrow from stack memory or heap memory, we can also get a slice of the data stored inside a vec. And it also counts as borrowing the vec itself. So here this code looks similar to the previous code, except instead of an array, we have a vector of i32s. So here again, by using ampersand x, we can get a slice of the data that the vec is holding. And then again, we can borrow a subarray. And then again here, we can't modify x because it's already being borrowed immutably from these slices that we use later on. To visualize what's happening here, x is a vector, so it'll store the length, like the current size of the vector, and then the capacity, how many elements it holds, and then it stores a pointer to the memory on the heap, right? When we have x slice, the slice stores a pointer to where the memory it's pointing at is, and also how many elements it can access, like the length of the length of the slice, basically. And here, since x slice, we are borrowing the entirety of x, the pointer points towards the beginning of the memory that x owns, and we store that it has length 5 because x has length 5. So x slice would be able to access this whole section of memory. In contrast, x slice section, since we're only borrowing indices from 1 to 3, we store that it has length 3, and instead of having it point starting at index 0, it points starting at index 1, and it knows it can borrow 3 elements starting from 1, so it can borrow this one, this one, this one. But under the hood, all 3 variables are pointing to the same memory living in the heap. To review strings and ampersand string slices, we know that string slices are immutable, whereas strings are mutable. That's kind of like the big difference. Another way you can think about it is that string slices are a pointer to memory, So you can think of it as like kind of a char star in C, where it's like an array of characters. Whereas strings work more like the string type in C, where they are mutable and it's like stored on the heap and it's all kind of abstracted away under the hood, and you can do more complex operations on them. So here are some ways as to how you can create ampersand strings and normal strings, string slices and normal strings. And then some more details. Again, basically, strings are also hold a contiguous collection of UTF-8 characters under the hood, and they are variable size again, not known at compile time, and it basically functions like a vector of these characters. In contrast, string slices kind of work as a like borrowing these U8s, these bytes under the hood, and you can get a string slice by borrowing from the strings heap array, and it also counts as a borrow of the string itself, and also you can borrow substrings. However, you can only use string slices on strings itself. You can't just directly borrow from a vector of U8s. So as an example, here we have a string, and we can create a string slice by borrowing from the string, and this will borrow the whole string. And then again, we can also borrow a substring by providing in some indices, and this gives a string slice to these three characters, E, L, L. And then when we print it out, it prints out what we'd expect. So we've talked about how strings are similar to a vector, and how string slices are similar to slices of U8s. But what about arrays? It doesn't really exist, but you can the string primitive type, which is what this string slice is technically borrowing from, works similarly to an array, in that it's also a contiguous collection of bytes. But the difference is that the size doesn't have to be known at compile time, and the underlying str type can either live on the heap or on the stack. So here, this creates a static string, and this data is stored in like the static section in the code. So when you borrow this actually doesn't point to the heap, it points to like the static section inside the code. And then here, where we have X as an array of U8s, this array lives on the stack. And then when we borrow, this string from UTF-8 basically tells it to like read this array, pretending that these are UTF-8 characters. And so this AND string will point back to the stack, to this data stored inside X. And then you'll technically like rarely ever use this underlying str type. It's mostly used in this string slice. This sums up all the content for this lecture. As a reminder, Homework 5 is released today, and it'll be due in a week. And then MP1 will be released tomorrow, and it will be due 2 weeks from tomorrow on Wednesday. Thanks for listening.